So we're in lab 5 now. So today we're going to be really talking about plotting. And so for plotting in general in Python, the major library we're going to be using is what we call Seaborn. That's like probably the most popular plotting library there is in Python right now, especially in academia. They have a lot of customization features and stuff that people like to use and everything like that. So we're going to be going with that. So just to get you guys started again, so to use Seaborn, right, we have to import the module. So we run this command, import Seaborn as SNS. And then what we're going to be doing after we import that, right, is using this, using these preloaded data sets. So that's another reason why we use Seaborn, is because it has these preloaded data sets called, they have a bunch of them. So we're going to be using the tips data set today, right? And we do that by just calling sns.load_dataset. And then we call the data set we want in here, which is called tips. And we're assigning that to the categorical data. We're going to name that categorical data, right? So let me run that up. And so let's just take a look at it and see what's going on with this data set, right? So as you can see here, right, we have what, 7 columns, right? So there's total bill, tip, the sex, smoker, whether they're smoker or not, the day they gave the tip, the time, and then the size of the party, right? So then this is kind of how data frames will be looking in Python. You guys saw that yesterday in lab 4. So when we're plotting that with Seaborn, right, there's a couple options we can go through. So the most basic, I think everyone should know what a bar plot is. If you don't, that's perfectly okay. But bar plots are pretty much like the most standard plot, I think, that a lot of people use to visualize just data frames. And so in order to create a bar plot in Python, right, and we're using Seaborn, we use this command called sns.barplot, right? So just to recap, right, SNS is the module Seaborn, and we're calling from that the bar plot function, because that's what we want to plot, okay, the bar plot here. And then within the parentheses is where we want to put all of the, like, what are we plotting, right? So here we're saying, okay, what is the data we're calling, right? The data in this case is the categorical data, right? That's what we loaded in. And then we have the X and Y axes, right? So X, in this case, we want it to be the day. So Thursday, Friday, Saturday, Sunday, like what day did they go to dinner? Or what day did they get food and pay a tip? And then Y is the tips, okay? And then that's all you need to do to plot this. If you want to plot days versus tips, that's all you need to do. Just call bar plot, say you're loading the categorical data, and then do X is equal to day and Y is equal to tip. And notice how for the X and Y, we are putting these in quotations. That's just the syntax that we have to follow here. So if I just put it in day or tip without the quotations, there would be an error here. So syntax is really important, again, for plotting functions, because that's how they know what you're calling. So say I wanted to create a double bar plot, like above, right? But I want them to be separated by sex. So it's the same plot, but I want in each day to know, like, what's the difference between male versus female, right? So in that case, we use the hue parameter. Okay, the hue parameter allows me to separate by any categorical or kind of like binary data that's in my data set, but I don't really want to plot that. I just want that to be visualized and separate them on the plot itself. So in this case, we're using sex for that. So as you can see here, when we do that, yeah, so you can see that when we do that, so you see how we get this little legend here, and it tells us, okay, so blue in the plot is male and orange in the plot is female. So we can separate that each day then, and I can get a better idea as to if there's any difference at all between whether males or females tip more, or if there's the same, exactly, something like that. That's like kind of what you get to do with hue. And hue is, you'll use that throughout all different plots. So one thing to note here is that when you do different plots throughout this, you'll see this later on, the format pretty much for all plots is pretty much the same syntax throughout. Like it's the same format, basically. You're going to be using hue, X, Y, data. All we're going to be replacing is this bar plot function when you want to call a different plot. We'll see that later. So another thing to note is that the bars in bar plot, they by default, without you changing anything, they represent sample mean. Okay, they represent the sample mean in your data set. And the error bars that are shown, these little black bars here, they represent the 95th confidence interval of each mean by default. These are just the standard things that's occurring behind the scenes. So we can change these defaults by loading in a different library in this case, and we call that library NumPy. So in order to import NumPy, we just do import. Yeah, what's up?
About the confidence interval. So if it's 95%, that means that there is a 95% chance that the value we choose is in that interval, or 95% of values are in that interval.
So 95% confidence interval means like whatever is plotted on here, it's within that interval. It's 95% sure it's going to be within that interval.
And the outside values are not calculated into this mean.
Yeah, the outside values are treated as outliers, basically.
But I don't get what does the black bar represent, like.
The black bar is error rate. So like the chance that for each of these plots, like what is the chance that this data is an error, basically. Like basically that means that it's incorrect, or it's incorrect, or there's an outlier going on. Like so, like if your data, like if it's not well distributed, and there's a lot of data points that are outside what we think is like the okay range, basically, say there's a higher error rate. Sometimes there's unrealistic value. There's a lot of unrealistic values, and then error rate just lets us know, okay, like what is going on with their data. Is it too high? If it's too high of an error rate, then we don't even bother plotting because we want to know. We need to figure out why there's a high error rate. Does that make sense?
Yeah.
It's expected to have some. It's expected to have some error rate.
Okay. Thanks.
Yeah. And so, okay, so now so we're importing NumPy here. We do import NumPy as NP. And then let's create a bar graph, right? But instead of plotting where each bar represents the sample mean, we're going to want it to represent the sample median, right? So remember, sample median and sample mean, those are two different concepts. If you don't know what those are, that's fine. Just let me know and I can explain that. But just moving on. So we can plot that here. It's the same format, right? So x equals to day, y equals to tip, data is equal to categorical data, right? So the way we change from sample mean to sample median, we do estimator, and then we call the NumPy function here by calling n.np. We do dot to call the median method, right? Median function. So we're saying we want the estimator for the bar plots not to be the mean, but rather the median, if that makes sense to everyone. So that's where you can see here, right below, we see how the error bars have kind of changed too, because the 95% confidence interval in this case is representing the median, not the sample mean. Okay.
Okay.
So you
but another question.
Yeah.
About the error bars again. So on the right, we see the error bar on the Friday is like more synced in. Does that mean that most values might be much more lower and just a little bit higher? And in the Sunday, for example, the bar is like a bit higher than the not so synced into the row. Does that mean that most values might be much higher but not much lower? Does that mean that?
Yeah. That's like the idea behind it. Yes.
Okay, thanks.
Okay, so we have a new bar graph. Let's create a new bar graph, right? But we want the error bars to be on the 50% confidence interval, right? So in order to change the confidence interval, we just call CI here. Okay, so we call CI, and we basically say CI is equal to 50. And that's it. That's how you change the confidence interval on a bar plot. That's on any plot, really, if they have confidence intervals. So we change it from, so by default, this CI is set to 95. If we want it to be 50, we just call 50. Everything else is the same. So you'll see as we go on more that the format for all these plots, it's relatively all the same. And that's why a lot of people like Seaborn, because you don't have to do very complicated things to change things, to change what you want to plot. So now if I wanted to create a new bar graph where the error bars now represent standard deviation. So in the previous plots, the error bars are representing our confidence intervals, okay? So now if I want to represent the standard deviation, I just call CI is equal to SD. And in this case, you see how these error bars drastically are different, right? These were plotting, in that case, the standard deviation of the data rather than the confidence interval. right? And so if another customization we typically do on these bar plots is we do error bar whiskers, and those are about 20% of the width of the category. And so you can do that by just saying cap size. This cap size function allows me to add these little horizontal bars, these error bar whiskers as we call them, and that basically gives a more definitive idea of where these bars are ending, rather than just kind of guessing with these vertical lines alone. And the cap size, you can change the width of it. You can make these bigger by increasing up or down. And that's pretty much all they're doing. Now, if I wanted to create a bar graph with error bars that are 100% of the width of the category, right? Then I just type 1. So this range will generally be from 0 to 1 is which one I go for. Beyond 1, I don't really know what reason there would be to go beyond 1. 1 itself is like a lot for these whisker bars. Now, the next step we're going to be looking at is after bar plots is box plots. Okay. Before I move on, though, was there any questions on the bar plots at all? Did the code make sense, basically, like what was going on with this? Any questions on the syntax or anything like that? We're not too concerned with the stats for you guys right now. We're more concerned you guys just know how to plot right now. So
by default, the error bars show what? Because we can change it to standard deviation, but by default it shows.
By default, they're showing the confidence interval.
Oh, the confidence, okay.
They're representing the confidence interval, and we can change them to standard deviation if we want to.
Okay, gotcha.
Yeah. Any more questions on bar plots before I move into box plots? Nothing. Okay, cool. In the chat, right? Yeah. Okay, cool. So box plots, right? So let's just do a quick review again. How to read a box plot, right? So box plot is basically kind of like a bar plot, except we're changing a little bit what we're looking at, right? And it kind of represents a little bit different. So we have a little box here, right, in the middle. And in the box, this box itself represents what we call the entire quartile range, okay? So entire quartile range, and then within that stuff, we have the quarter 1 at the end here. We have the median in the middle, and then quarter 3 here. So one thing to note here is by default, we're looking at the median in the box plot, but in bar plots, by default, we're looking at the mean, right? And typically, again, you'll have these error bar whiskers on the front and back of it, and you'll typically have these dots that come on the outside of these error whisker bars, right? And these dots are representing our outliers. And these end of these whisker bars here represent the minimum and maximum is what we term in this. So the minimum is the quarter 1 value, or the 25 percentile value of the data set, of that like column you're calling, or that data set you're looking at. And it's minus 1.5 times the IQR range, right? And then the maximum is the quarter 3, or the 75 percentile of the data set, plus 1.5 times IQR. Okay, and so we're not really gonna like delve too deeply into what these are, like the stats beyond this. We just want you to kind of understand what's going on in this box plot in general. So when we're doing box plots, you'll see here, it's the same format as I was doing with the bar plot, basically, right? All I did really to change between bar plot and box plot, if you look. Bar plot has data equals to X and day, X equals day, Y equals tipped. Box plot is data equal categorical day, X equal to day, Y equal to tip. All I changed was bar plot to box plot here. And it'll call it, and then it'll plot it. That's it. And you'll see here, right, we have these little dots, these little diamonds. Those are your outliers. So you can see here, Saturday has a lot of outliers, while Friday and Sunday have nearly no outliers. And this also, it's also a little bit different because we can actually kind of see, we can kind of see where Sunday has like a different distribution. We can kind of look at distribution here with box plots. So to create a box plot like above, but say if I want to get rid of these dots, right? Because these dots are kind of showing that Saturday there's a lot more outliers here than Thursday, and I just want to like look at purely just the box plot area, right? So we can remove the outlier points then, and then we just say flyer size in this case is equal to 0. So flyer size is outliers in the Python language for Seaborn. Okay, so if I say 0, it'll remove the outlier points. It's not like those are gone. It's just we don't want them on the graph. Is basically what's happening. Now, if I wanted to create a double box plot like I did with the double bar plot, where the mean tips were separated by sex earlier, as we did, where is it? Here, right, where we separated by sex, it's the same parameter. We're just going to be using hue again. So we separate when you call hue, right? And I want to keep my outliers because I don't want any outliers in the graph. I just say hue is equal to sex, and then it separates it again by the box. It separates it again by sex on the box plot. So you see that here, and we can basically look at it and see if there's any differences between male or female again based on the median values. Again, this middle line in the bar that you see here is the median, not the mean. It's going to be the median for box plots. Any questions on box plots before I move to strip plots? Nothing. Okay, cool.
So the bar in center of box represents the median, right?
This represents the median, yes.
Yeah, but the box itself represents the distance between the 25 percentile and 75 percentile.
Correct.
So why isn't the median right in the center where is the 50 percentile in the examples we made?
Yeah, so typically, yeah, ideally, your median is going to be the 50th percentile, but just the way your data is distributed, it'll tell you if your median is more shifted towards the left or the right, because sometimes distributions will be left skewed or right skewed, right?
Mm-hmm.
So that's kind of like what we're looking for here.
Okay.
The median is not always, the median, and theoretically, yeah, where we always be in the middle is the 50th percentile, but because of the way the data is distributed, sometimes it's not the case. Like visually, it's not going to be in the 50th. Visually, it's not going to be in the middle, but it is still the 50th percentile.
Mm-hmm. Okay, thanks.
Yeah. So strip plots, right? So strip plots are a little bit different. They're kind of similar to box plots, but visually very different, right? This is a box plot. Strip plots is just dots, pure dots, and they just go up and down. That's it. So in terms of that, so the difference between these is box plots. It's hard to tell a distribution. It's kind of hard to tell the distribution because it's doing median. We're doing a median value here. So box plots don't really describe a data's distribution in the bimodal sense, nor its sample size. Unless you specifically call and add those values to the box plot, you're having it's sometimes harder to just decipher that from that. So we use strip plots for that in this case, because we can actually see where there's a heavier amount of data, where there's a lighter amount of data on like distribution wise. We can tell if it's skewed left or right, basically. It's easier to tell that in this case. So strip plots, right? We show all the tips on each day. So X is equal to day, Y is equal to tip. Same format, right? All I just changed was box plot to strip plot. Okay. That's all that we did different. We just changed box plot to strip plot, the format inside of the parameters in the parentheses, same thing as last time. And we notice how the positions of the data points are randomized each time the code is run, right? So first time I ran it here, right? And then the second time I run it here. So they kind of change here, right? It's still in the same kind of place, but it's still the same y-axis value. The y-axis and the x-axis values are going to stay the same, but the actual position on the graph is just going to be kind of random because we're not actually, like, they're still in the same category, but it's not in the exact same point. So you see like this point here versus right here, it kind of shifted a little bit. But that's pretty much it. So the other parameters we have in this is if I wanted to change, like, say, the markers, right? If I don't want these circular dots, if I want to change them from circles to triangles, by default, it's circles. I can just call this marker parameter here and change it to triangles. And to do it with triangles, all I have to do is do this exponent function, which you'll get by Shift 6, okay, on your keyboard, Shift 6. And the size of it, if I want to change the size, I just call the size parameter and I set that to equal to 5. Okay, that's pretty much it. There's a bunch of other markers you can do too. If you Google like SNS strip plot and look at markers, they'll give you a bunch of options you can do with that. If you don't want triangles, there's like squares and all these other things. So if I want to create a strip plot, right, like this one, but I want the points to be more spread out, right? So we use this parameter called jitter, okay? So jitter is kind of like, how to explain this? It's like a randomization of where the points are on their respective columns, kind of. So I want them to be more spread out, or like how spread apart they are. Jitter is like kind of like randomness in this case. we call the jitter parameter. And so by jitter, default jitter is set to 1, right? So when it's set to 1, it keeps it very tight, and narrow. But if I want to be more spread out, I'm going to lower it. So by setting it to 0.3, it widens my columns and makes them more spread out. So in this case, it lets me a little bit discern better the points and how different they are. Because here it's a little bit more clustered at the bottom and a little bit more spread out at the top. But here at the bottom areas, I can kind of see now where the points are and how they're spread out more, basically. So the whole point of this is look at distribution of your data set. That's the whole point of this plot. So we use jitter to basically make that easier on us by manipulating jitter of a plot. So to create a strip plot like above, what we opacity or alpha value of each data point. So opacity is like how how solid is each point, basically, like visually speaking. So in this case, so you see here how there's a bunch of points that are overlapping with each other, but because of the same color, it's really hard to tell individual points from each other and how many more data points there are. So we mess with the opacity value in this case, and the opacity in this case is messed by using the alpha value, the alpha parameter. So by alpha parameter, by default, alpha is set to 1. So by when alpha is equal to 1, opacity is at 100%, meaning that all points will be completely solid. Well, now when I set alpha to 0.6 or 60%, right? So you see how these points became a little bit more lighter. So you can see now between the overlap of points where the individual points are. So that because there's different opacities that are being used. So the ones that are behind each other, so you can see the points behind each other and make sure that like where the overlap is actually points and doesn't just look like a cluster of points, basically. Because when it's like this that we had earlier, it's really hard to tell what the points are doing here. It's really hard to tell because they're all really clustered up, and it's really hard to see the individual points. So that's why we mess with alpha value. So again, if I wanted to create a double strip plot like we did it, and we want to label the colors based on customer sex, we just call hue again, right? Same thing, and I wanted to label it by sex, I call hue, and now I can see here that blue, yeah, I can see where the blues are and where the oranges are. But say if I wanted to separate the points now based on their color, right? You see how the points are all mixed up. So what we can do is called the dodge parameter. The dodge parameter in this case will separate the points by the hue. And so by default, dodge is set to false. But if we set dodge equal to true, we see here then that the points will be separated by the sex. So on the left will be men, and on the women will be women, right? And then so it does that throughout the plot, and then that way I can tell what the differences in distribution are. One based on Thursday, Friday, Saturday, Sunday, but also based on hue sex, by the hue, which in this case is sex, which is a very useful thing to do because then you can do multiple variables to see what is affecting really the distribution. Okay, I think that's, yeah, so that is all the plots actually. So that's all the plots we're gonna go through today. I know that was a lot if you haven't done this before, especially. So definitely review this as you're going through it. And it's 11. Okay, so we actually did that really quickly. Are there any questions, or we can move on to the lab right now, and I can kind of walk through it and talk you guys through it, and we can get you guys started on it. But the lab is pretty much very similar to this. I recommend when you guys are going through this, just keep jumping back and forth between the lab lesson itself, because it has the code for you, and you guys will basically be able to decipher like what we're going to be using in the lab. That's the easiest way I recommend to do this in general. But are there any questions on previous plots before we move on to the assignment? Okay, no questions, nothing?
Yeah, there's no question in the chat box either. So maybe we can jump into the assignment.
Cool.
Just a question in terms of plotting and different types of plotting. Which ones you believe that are more readable and comprehensible for people to read?
Yeah.
So it's like, how do you classify them, or how do you select them? Which ones are the most appropriate for your research and so on?
Yeah, so that's the question of the day, really. Kerry will agree with me on this. The point of learning these plots is the more you use them. So there's no real good answer for that, in all honesty, because it really just depends on your research. It really depends on what you're doing, and that's like kind of what we want. That's like kind of what you're going to see in this assignment is, and I think in future assignments, there's no real straight answer as to what's the best plot. There really isn't. It's really depending on the situation and like what you're trying to show and what you have in your data set. So that's kind of something you pick up the more and more you plot and the more you do this type of stuff, because that is the question of like, which plot is the best plot to do this in, and it's always like it's just an opinion half of the time. Obviously, there's some cases where definitely one plot will be better than the other, but yeah, I don't really have a straight answer for that because there is really no straight answer. Terry, do you have any comments on that?
Yeah, I guess I agree with you that it depends on what you want to present.
Yeah.
I think in our case, usually you do like probably like a box plot. So you can kind of show the medium or the mean values, and also you can add the strict plot on top of it as well. So you can show the kind of where the individual numbers or individual values are. So I think that is one way we do it. But then there are lots of other types of the plots that you can plotting. So it really depends. Like there's some like Violin Plot, and then there's some other things. So it depends on what you want to show, I guess.
Yeah. And like for each plot, obviously there are certain conditions that you are required to use them in. So like you can, I mean, I don't think we really went over them specifically today, but if you Google like when should I use a box plot? When should I use a bar plot? Or stuff like that, those will show the conditions, because there are certain situations where you should never be using these because sometimes your data set doesn't fit those requirements. But in general, like most of the time you're fine. You're pretty much good to use them. It's more just like, do you think this is the best way to represent your data, basically? But typically, yeah, like Terry said in our lab, we do a lot of box plot, strip plot stuff. But then also there's like, I don't know, sometimes there's like a lot of custom figures sometimes too, where it's just like depicting like a workflow or something like that too. So it just depends. It's really depending. I don't want us to give you like a straight answer because like there really isn't, in my opinion.
Yeah. I thought there are certain criteria that tells you like, for example, we have a lot of data, and for a lot of data, for example, don't use these plots because they're getting messy. And this is the reason why you want to make something more comprehensible and readable, and that's why you use something else.
That does happen. That does happen in general. I mean, for the data sets we're going to be using this class, that's not going to really happen. But for like, I guess you kind of like clinical data, right? Like clinical data, patient data kind of stuff. Yeah, I mean, like what type of plots? I guess could be like, I guess you could use like heat maps and stuff. I've seen that before with clinical data. People do like dendrograms and stuff, I guess. I don't know, like what else really.
I got it.
But,
no worries.
yeah.
I understand. So
yeah. Sorry if it's not like that straightforward an answer, but yeah, I think that's always the question of the day. Like, what plot should I really be using right now?
Yeah, got it.
Yeah.
Good. Thanks a lot.
Okay, cool. Is there any more questions, or we can move on to the assignment itself and get you guys working, because it is only 11:16, so you guys should have like an hour and a half probably to get through the assignment if you guys want to, or if you guys want to do it later, that's fine. I just want to walk through it with you guys to make sure there's no questions or anything.
Yeah, I think we can do the assignment meanwhile.
Okay, cool. So in your own Google Colab, right, you're going to be using the commands. We give you guys some commands already to go through this, but you will have to just decide like what plots to kind of use. We do tell you like what kind of plots you could get in this case, though, because this is the first time. So for this case, we're going to be loading this. Lab 2 data set is going to be the Titanic data set. So the Titanic data set contains information about the passengers who were aboard the Titanic. And basically, we're going to explore this data set to see what happened during that day. So for anyone who doesn't know what the Titanic is, it was a ship, very famous ship. They made a movie about it and everything, which it sank during its maiden voyage after crashing into an iceberg. So we're going to explore the data set, see if we can learn anything about like what happened that day and what happened to the passengers, like that. So to that, we're going to be using a bar graph to investigate whether the type of booking, right, first class, second class, third class booking on the Titanic may be related to the passenger's mean survival rate. So we have the plots here for you on this exercise. So you know if you did your plot correctly or not, but we're not giving you guys the code. So that's what we want you guys to do, like just figure out what the code format is for this. So in this case, you're looking for a bar plot, right? We're looking for a bar plot, and you're plotting we get to look at the data set, right? And when we look at the data set, you'll see what the values are. So in this case, you're looking at the class column versus the survived column when you guys are doing this one. And just to brief on that, it appears that there may have been a monetary wealth basically. So whether first, second, or class, right? Because if you're first class, you're paying more money, which means you're probably wealthier than the other classes in the vote. Played a role in whether a passenger survived the destruction of the Titanic. So we can see here the first, it just decreases, right? If you're a higher class, the more likely you were to survive in this case. But this is just a bar plot. So there's not really much to confirm from that. This is just like an association kind of thing. Next, right, we should investigate whether the individual was a man, woman, or child. So in this case, we're separating by whether they were man, woman, or child in the hue parameter, right? And whether that child could be a factor, the influence passenger survival rates. And then your graph should look something like this again, right? See how we're separating by man, woman, and child. And based on that, right, we can say there is like a significant difference based on the bars between the survival rates of men versus women and children, regardless of the booking, right? And let's see if this type of difference is also present among children by separating them into boys and girls, right? So in this case, we gave you the code to separate them. So to try to read the code, I think this was gone over before. I'm not sure if this was done yesterday or not. This should have been done yesterday with the data frame stuff, but if it wasn't, we can just quickly go over it. So when you have a data set and you want to locate a specific value, and basically, in this case, we have child, but I want to separate the child category into boy or girl. Like, I want to separate them by their sex, right? So we use this locate function, .loc, L-O-C, and then we call it within these brackets, right? This brackets is the overall thing. And this is like a little bit of a more complicated piece of code, but we have these brackets, and within it, we're basically saying, okay, I want to locate within lab data 2, and within the column who, and I want to locate anything that's equal to child, right? So we do equal in this case. Equal in code. I don't know if you guys went over this yesterday, but I'm just making sure. Equal in pretty much all programming languages is a conditional statement. It's not the same as just saying is it equal to. It's equal is saying is this equal to this. It's a conditional statement. So I'm basically looking in the who column and saying, okay, is this cell value, is the first row cell value in who equal to child? So if we're saying we only want the values in that column that are equal to child. And then this and is we're doing another command. We're saying, and I want anything in the sex column. So in the first line, I'm saying I want anything in the who column that is equal to child, and anything that's in the sex column that is equal to male. And then that way I'm saying, okay, let's make that equal to boy. We're saying we're going to make a category called boy now for that. Okay. And we're going to rename that category to boy. So we know that's a child and he's a boy. We know he's male. And then similarly in the second line, we're going to say, okay, I'm looking in the who column again, and I'm saying, okay, must be a child, and the sex must also be female. And in that case, we're going to label that girl, right? And then we basically want you to do the same thing, kind of like last time where we separated by who, but now instead of having just child, I basically replaced it with boy and girl by doing this. So we did this for you guys. We just want you guys to understand what's going on. You guys just have to, again, just look through the plots. And so it appears that, again, individual sex was not a strong predictor of the survival among the Titanic's children. So it doesn't seem like there is anything to do with sex with survivability rate right now. So now we want to obtain a graph. We want to share, but let's address some specifications or some details so we can use some of the stuff we learned earlier, right? So in this case, error bars by default, right, are representing 95%. We want you to change them to 90% instead. And the error bars, we want you to give them whiskers of a length of 0.05. And again, all of this stuff is in the previous exercises we were doing in this lab. So you just got to look through and just kind of like coordinate that. And the graph again will look kind of like this. Don't worry if your legend shows up in the middle or different places in the graph. That's fine. That's just what happens sometimes. There's ways to fix that, but we're not really getting into that today. That's just part of like doing like the key parameter. Now again, what's next? Okay, so now let's take a closer look at the passages themselves by plotting the ages of those who survived and those who didn't. The graph you produce should look like this, right? So we're looking at survived and age in this case. So this is the first time we're changing our X and Y's now. And we did a hue parameter here too by separating by that. So keep that in mind when you're making this graph. And again, from this, we can look and see that the majority of the adults on the Titanic were around the same age, while the majority of the children were around the same age as well. So the first improvement, right, we can do on this is we can rename the X and Y axis, right? Because it's saying 0 and 1 right now, because that column of survived is binary. It's set as binary, which is just 0 and 1 in this case. But now I want that to be, did they survive? Yes and no, right? 0 and 1 is like not really clear if you're not really familiar with the data set, right? We want someone who doesn't really know much about this data set to come in and be able to observe the graph and say, okay, I understand what's going on in this, right? So in this case, what we're going to do is we're going to change the 0s and 1s to yes again, yes or no, and we're going to be using the location function again. So in this case, all I need is to locate again, right? In the survived column, anything that's 0, right, which is mean they died, or 1, which means they survived. And basically, I'm going to create a new column now called survived underscore string, is what this is doing. It creates a new column called survived underscore str. And I'm telling it that if on the column in survived, if the column is equal to 0, if the cell value is equal to 0, set the cell value in the same row in survived str as no. And then same thing here, if the survived in the cell value on a specific row is 1, set in the same row on the survived string column as yes. And if you want to look at that after you run this code, just call lab2 underscore data, and you'll be able to see that too, is what happens. So I can do that quickly, actually. Let me load the data set, actually. Okay. So we call lab2 now. You'll see here this new column is created, survived underscore str. So that's kind of how you create a new column based on another column value. So if you're trying to basically make an actual categorical variable rather than using a binary variable. So by binary, again, binary means 0s and 1s are basically, there's only 2 values that exist in that column. And so in this case, survived is a binary column. It's a binary column, there's only 0s and 1s. And basically, we just wanted to change that to no's and yeses. And then again, you guys are responsible for making this bar plot. Now that we've seen a graph, we might want to share again. Let's adjust some specifications. So in this case, we want you to change the error bars from confidence intervals to standard deviations. The error bars should have whiskers, and that should have a length of 0.5 and I think they meant width here in this case, actually, a width of 0.05. I think that's what they meant. And instead of sample mean, the bar should represent sample median. And remember this, for this, you have to import numpy, which we should have done earlier anyway. I think we did it in another, yeah, we did it here. Oh, no, we didn't. No, we did not import numpy. So you guys have to import numpy on your own too. And your graph should look something like this. Now, so the bar plot's complete, right? But there's probably better ways to represent this data and to produce a graph more worthy of publication. So let's use a box plot and a strip plot instead. So again, we showed you guys how to do box plots. It's pretty straightforward. It's the same kind of format as bar plots, and you guys are just changing. Nothing's really changing here. All that's changing is you're using a bar plot instead of a box plot instead of a bar plot in this case. So when we look at the inclusion of the outliers, it does not change its scale much, so we can leave them in, right? So we don't have to really worry about these outliers. However, if the data really contain a lot of extreme outliers, remember we removed them by using flyer out. Flyer size is equal to 0. That removes all outliers and box plots. So let's do a strip version of this, a strip plot version now. That's what we want you guys to do. And we want you to set them to be half transparent. So by half transparent, remember we're saying we want the opacity to be 50% or the alpha value to be 0.5, right? And jitter, set that to 0.03, so the points are a little bit more spread out rather than being super narrow. And since the position of the points, a strip plot is randomized, the graph is going to look similar again, but not exactly the same. It's not going to look exactly the same. It's just because that's how strip plots work. And then once you do that, you are done. That's all the plots. So you should have you should have 3 plots, one for each of the different types of plots we learned today after you've done through all the changes we made to them. But yeah, that's all of lab 5 itself. So once you guys get started on that, and me and Kay will be here to help out with any questions or anything that you guys have. Cool. Okay. Yeah, me and Kara will be here. Just let us know if you guys need any help or anything. Happy to help out.
Okay, thanks. We'll ask.
Yep.
Ram, I have a question.
Yeah, what's up?
When we create a new variable, this variable is survived string, and if we use it, so of course instead of survive we will have survive str.
Yeah.
Do you expect us to change the x-axis label?
Yeah, that's exactly how you would do it.
I think it's important to mention, when we put the survive str, so we will have, instead of survive, we will have survive str, and we may not have to change it. It's a very important moment.
Yeah. So, that's what we want you guys to figure out, because because you have to basically, when you guys are plotting, right, you have to decide what's my x and y going to be, right?
Yes.
Someone's not going to really tell you.
You can change whatever you want on these graphs, but it's important to mention this. Thank you.
Yeah.
Okay, so we are dealing with Seaborn. Okay, so we are dealing with the Seaborn library. One thing to know about Seaborn is what happened. Yeah, Seaborn is dependent on matplotlib. I'm not sure if you have done matplotlib. So have you done this matplotlib library before, like in the previously?
We only did Seaborn, I believe.
Okay, then I will have to rest. Okay, so I will have to restrict to Seaborn only. So yeah, so matplotlib is another library which is also widely used for plotting the graphs, but Seaborn has some aesthetic effects, or I would say to make beautiful graphs, but the same results can be gained from this matplotlib as well. But anyways, so yeah, so Seaborn is actually dependent on the matplotlib, and yeah, first is this simple importing the data library. So what will you do is you will just import Seaborn, Seaborn as SNS. SNS is a common alias, so you can use some other alias like I would say, sorry, say like I like pizza. You can use this alias as well. Import Seaborn as I like pizza, but at the end you want to shorten the name. So I like pizza is too long, and it will make your code a bit of I would say hodgepodge. Then yeah, so it's better to use SNS only, okay, or some other short key, short term, say SN maybe. Yeah, but SNS I also prefer SNS only. Okay. All right. First thing is to import the library. Okay. For every code, you will have to import the library first. Import the library. Otherwise, you can't use their functions. Okay. So SNS has its own, its own data set, which is called a TIFF data set. Okay. So some of the modules have these kinds of data sets. So there is another library called, I would say, scikit-learn. Scikit-learn. This is mostly used for machine learning tasks. Okay, I hope you are a bit familiar with the name actually. Mostly used for machine learning tasks. it has a a bunch of data sets actually. It has a bunch of data sets. So yeah, so some of the libraries have these kinds of data sets. Okay. So yeah, so one of the data sets which this Seaborn has is this tips data set. Okay, and when you load this, so it will give you a pandas data frame. Okay. Okay, so what will it do? What will it do is it will just give you a pandas data frame. So it will load the data set, okay, and will give you a sorry pandas data frame. Okay, simple as of now. I think everything is simple, and we are assigning it to a variable which is categorical underscore data. Okay, you can view this data set using categorical data dot head, but I will not do it here because it's already in the main notebook. So let's delete it. So yeah, so categorical data. So we are loading the data set, which is regarding the tips. Okay. So yeah, so this data will have all these columns: total bill, the tip which is provided by that person, sex of that person, smoke, like if this person was a smoker or not, and on which day the tip was provided, the time. I think this time means the the food at I think the food that these guys were eating, and size. I'm not sure about the size. Have they mentioned size? Okay, I don't have any idea about the size. You can take it some variable. I don't know if it's a. I think it's a categorical variable, but I hope you guys know what a categorical variable is, right? I think this thing was taught.
Yes, yes.
Okay.
I think yes.
All right. So categorical data. So each of these columns, except for this total bill and this tip, all these columns are categorical because it is having a category, maybe male, female, smoker, no, yes, days, and Saturday to what's the day, Monday to Sunday, and time is dinner or I think we have 4 times in America. One is dinner, breakfast, or lunch, and some evening snacks or something. And size, I don't know what is this size. Okay, so yeah, you can display this. So yeah, all right. So next thing to do is to plot this. So all right. So as I told you, a Seaborn is mostly used to, you know, what do you say, is to make the graphs look good. Okay, that's the major reason for using Seaborn, and it has a bunch of more plots than the what do you say, Matplotlib actually. Right, so it has more plots than Matplotlib. I don't think Matplotlib has what do you say, this a strip plot or something. I don't think those guys have this thing, but a Seaborn does have this thing. Okay, so that's why uh, I think that's why Seaborn is being taught to you. Okay, yeah. So yeah, once you load the data, so first is to make a bar plot. Okay, first is to make a bar plot. All right. So make a bar plot. For most of these commands, you will observe that the first input that this functions take is this data to which type of data, or like for which data you want to make a plot. Okay. Yeah, so that's always the first input for this. So in this case, you can see we are giving the input as a categorical data. Okay, and then we will have to show okay, we will have to give the name of the, what you call this, axis, I guess. I think it's called axis, the horizontal axis and the vertical axis. So this is the horizontal, this is the vertical, and we will have to give a name. So if you want to give a name, say I like pizza. Yeah, so for Python code it is correct, but for for from the reader point of view it is not correct. So best is to use, some cogent, or I would say some correct terms rather than that by like pizza stuff. So make sure you don't use these terms. Y is for the vertical axis, as you can see tip. Y is for the vertical axis. Y is for the vertical axis. X is for the horizontal axis. Day. Okay. Edge color. Edge color. Edge color. What's an edge? This is an edge. This thing is called an edge. Okay. Yeah. So this thing is called an edge. So we want the edge to be black. So that's a simple thing. Face color is white because the plot. So the what do you say? This palette is white. Palette means this big box of this plot. I think that's the face color, I guess. Yeah, that's the face color. And cap size is caption size. So I think it is talking about this Thursday, Friday, Saturday, Sunday, and this 3.5, 3, 2.5, and all these terms. Okay, and this tip and day as well, I guess. Yeah, so that's the cap size. So if you want to enlarge it, then what will you do is you will just increase the size of this. If you want to make it more readable or something, then you can increase the size of this. Okay. Yeah, let me just run this actually, or I will just run it here as well. Yeah. And if you want to say, let's go with this one. Change the edge color to red. And what color will be a good contrast to red? I would say, yeah, let's keep it white only. And cap size, let's keep it to 3.3. Then let's see what happens. Okay. Oh, sorry. I think the cap size is this one, this top bar. Yeah, so that's the 3 point, what the size? 0.3. So that's why when I increased the cap size, so this line got increased. Okay. Oh, sorry for the mistake. Yeah, cap size is this one. Okay. This, I would say I like thing. That's called the cap size. Okay. Yeah. So as you can see, like I also don't know the meaning of this cap size. What I did was I changed the values of these parameters, and yeah, and then you will get your correct results. Okay, all good. So yeah, let's go ahead. Okay, edge color is this. Okay, face color is the color of this bar actually. Okay, yeah, let me just write this. So edge color is the color of the edge, as I told you, color of the edge. And face color is color of this bar. Okay, and what was that? Cap size is basically this cap only. I think it is not caption, it is cap. Like this thing is the cap actually, so that's the size of the cap. Okay, so yeah, that's the size of the cap. Okay, so yeah, you can play around with these parameters. You can change the cap size, you can put some other colors and all these things. So yeah, that will make it look more better actually. Okay, next is the, all right, so this one was the bar plot. Next is our box plot. So I think you guys know the difference between a bar plot and a box plot. So in box plot, you will have the quartiles and the outliers here. I don't see any outlier in this case. Okay, and this horizontal line is the median, and this top line is the third quartile, and this I would say the lowest. Sorry, not the lowest. The lower line is the first quartile. So this lower line is the first quartile. This is the median line, and or I would say second quartile, and this third one is the third. This what do you say? Upper line is the third quartile. Okay. Yeah, same goes for everything, and yeah, and all the parameters are the same. Okay, we have something more different. So, so in this case, you can see, face color is black. Sorry. Edge color is black. So all these edges will be black. You can change it to blue or something. That will, I mean, that won't make any difference. Okay. Yeah. All right, let's play around with these parameters now. So yeah, so the first is the data. Then you will have to label the axis. I don't know about this flyer size. Okay. And edge color is black, and face color is this color under the box, this box. Okay. And we have given a particular code to this. So yeah, let's try changing this. So when we put 1 and flyer size, let's put it 3, then see what will happen. I didn't see it. I don't see any difference out here, but anyways. Okay. So yeah, so this color has a bit changed, but I don't think we can go with this. We can also try using, let's use gray. Let's see what happens. So this 1110 is actually a color code for this 1110. I am also not sure about this code, but yeah, but you can also Google this thing. So yeah, so as you can see, like if you don't know the function of a particular code, what will you do is you will just type that function, okay, and you will get that documentation boxplot seaborn.0.11.2 documentation. Open this documentation, and yeah, and you will get all the parameters, actually what all the parameters are. Okay, yeah, these are all the parameters. Okay, so yeah, you can work with this or play around with these parameters to get a better understanding of these things. Okay, yeah, I think I also like, I mean, I remember most of the code I learned from this, going over this documentations and all this thing. But yeah, so it's kind of better to use this normal colors rather than this code. This 1110. I am not sure. Dotty, do you know about this code 1110? Dotty is here, I guess. Okay. I don't think she is here, so yeah, we can go ahead. So yeah, I'm not sure what is this code for, but you can also like you can always use the color, actually. Okay, you can always use the colors and all these things. I think it's better to use the color because it's kind of more intuitive rather than using this for digit tuple or code something. Okay. All right. Next is the opacity. So how opaque you want to make your dots and everything. So that is always given by this parameter alpha. Okay, I don't know why they have named this opaque parameter as alpha, but yeah, but that's the parameter. Alpha is 0.5. So for most of the plots in in Matplotlib or Seaborn, so you will encounter this term called alpha. Okay, so this alpha basically makes it a bit blur. Not blur, I would say a bit light in color. Like if you have, like if you are using dark blue, then it will change it to light blue. Oh, sorry. Yeah, yeah. Light blue and these things. Okay. Yeah, so you can use this, but I like really don't feel if it makes a difference or something. Okay, but it actually helps in like if 2 points are kind of uh what would you say, if 2 points are coinciding with each other, so at that time having a lower opacity will help. Okay, so uh, this alpha value takes value uh, from 0 to 1, where 1 is the most opaque color. Okay, and this 0 is the and this 0 is the like completely transparent, or I would say no color. But I don't think these guys use this 0, so they have a very small value, I would say 0.1. So like even if you place 0 here, then I think it will show you some dots. Okay. Oh no, it doesn't show any dots. Okay. So 0 means a no color, or I would say transparent. Yeah, so it's better to use to put some value actually. I think rest of the things are intuitive. I guess this is a, what do you say, a strip plot. Okay. I don't think I have seen any, paper with this using this strip plot to show their results. But yeah, but I think if you have seen somewhere, then you can make this strip plots with this Seaborn. Okay. All right. So have I run this command here? No. Okay. Yeah, and another thing is about this. So you can actually play with this thing. So we have in graphs, in Python graphs, PHS, we have something called palette. Have you seen an art palette, by the way? Let me show you an art palette. Art palette, yeah. Not a palette, I would say this is a canvas. Yeah, this is a canvas. Yeah, so this is a canvas. So what you do in a canvas is, I don't know why is it coming. Yeah, this is the canvas. So what you do in a canvas is you will put down, a bunch of colors here. You will put a green color, red color, blue color, black color, and make some drawing. Okay, like similar to this. So earlier it was a pure white canvas, and now you have put in some colors. Okay, so same thing goes with this one as well, with this thing. So I would say it's a canvas rather than a palette. Okay. So it's yeah. So in Python also this, so it is also having a canvas out here. So if you see this white thing, so this is actually called a canvas. If you are looking in terms of Python graphs, so on canvas you can make multiple graphs. So you can consider this graphs as a kind of a color, say a red color, a blue color. Okay, and then you are painting it over again, like over and over again. So yeah, so that's kind of a canvas. So you can consider this as a white canvas, and on this you can make two plots or more than two plots actually, I would say. Okay, so how do we make two plots? It's simple. So first you write the code for the first plot, and then you write the code for the second plot, and it will make you the canvas. Like, and there's two graphs on the one on one. And you can also change the order of this, so it does not matter which order comes first. Like it is not order dependent thing. Okay, it is not order dependent thing, but yeah, but you can do this actually. Okay, if you run this command, it will make two graphs, or I would say two graphs at the same point. So you can use see this strip plot and this what do you say, this box plot at the same time. Okay. All right, let's go ahead. Yeah, let me just run this. Yeah, and same thing is happening with this box plot. Okay, yeah, you can make two graphs, or I would say, yeah, let's make one more graph, I would say. Yeah, but the graph is not into it. Like if you try to make a box plot on this bar plot, then it will be a kind of a bad thing. Hey, let me just show you actually what will happen if you put a box plot on this bar plot. Sorry, what happened? Yeah. Yeah, so it is kind of rubbish because you are just, yeah, the two graphs are like coinciding with each other, and it is not making any sense. It's kind of a nonsense stuff. So yeah, so make sure make a correct decision while making the plots. Like whenever you are coinciding two plots, so make sure that you are taking a correct decision in choosing the plots. Okay. All right, so that was all for the box and the bar plots. So are there any doubts in this? I think the concept of box and the bar plots were taught in the lecture, I guess. Yeah, any doubts, any questions here?
I think it's okay.
Uh-huh.
No.
Okay, so yeah, so that was one part of the plot, which is the bar and the bar graph and the box plot. All right, let's go with the violin plot now. Violin plot is something related to the kernel density estimation. What is the kernel density estimation? Kernel density estimation. Yeah, these are some terms actually. Okay, so first you need to understand is that this is not an estimation. We are not doing any estimation out here, so this term is actually wrong, I would say. Okay, this term is wrong. We shouldn't be using this estimation term out here. So yeah, because kernel density estimation is a machine learning topic where we estimate something, but here we are only working with the kernel density only. Okay, we are only working with the kernel density and we are not doing any estimation out here. Okay, so what is this estimation, kernel density thing? So it will tell you the probability where most of the data lies. Okay, so when you look at this plot, so what you can see is you will have this whole line. Okay, and yeah, and it's kind of an expanding stuff, right? So it is expanding like this and then it's contracting. So what it means is that most of the data lies near the median. Okay, so that's why it's having a kind of a high probability. Okay, so yeah, that's basically the purpose of this violin plot. And yeah, and same is this case. So yeah, it will tell you where the most of the data lies. So if you have a contract or I would say a tail like thing, then it means that there are less data points out here. But if you look at this point where it's kind of a peak, then you can say that it's what do you say? It is having a larger data points, a large number of data points here. Okay. All right. So that's a violin plot. Okay. Violin plot has an issue. Yeah, I think most of this is most of the parameters are I think you are aware of. This is the what do you say? This x-axis and y-axis, and this is the data. So I think I think this is simple. You just have to change the name to violin plot. Okay. It also gave you a bunch of parameters as well. Okay. Next is a violin plot with a scale. Okay. What is the scale purpose of scale? So basically, if you see, okay, let me just plot this here. Okay. By the way, violin plot has a bunch of more parameters. So how will you know which parameters are there and which parameters can be useful to you? You just have to put this violin plot out here and yeah, just go into the documentation and all the details regarding all the parameters are mentioned here. For example, x, y hue, what will this do? So yeah, inputs for plotting long form data, see example for interpretation. So you can go to the examples right here, and yeah, and you can understand what this thing is doing. Okay. Okay. So I think these things are kind of more intuitive when you work with this documentation. Okay. So yeah. All right. Next is the violin plot with the scale. Yeah. So what is the scale? So as you can see, we are working with categorical data, and yeah, and there is a categorical variable. So yeah, let's give me an intuition here. So suppose for Thursday, you are having say 12 samples, 12 samples of data. We also call this as data points. Okay. We are having 12 samples of data points. So it's kind of an example. So it's not the real case. For Friday, say we are having 100 samples. For Sunday, say we are having 10 samples. So each of these days can have a different number of samples, right? For Thursday, we are having a 12 samples, and all our observation will be based on these 12 samples. Correct. And for hundreds, yeah, for the Friday, all our what do you say, all our parameters, or not parameters, I would say observations will be dependent on this 100 samples, and for Sunday it will be dependent on the 10 samples. So this a low number of samples can bring a bias, or it can give an incorrect observation. So what we do is we just divide that thing by the number of samples. For suppose if you have this pay, or I would say tip, not tip, I would say pay, for all Fridays, the sum of this pay was say $100, $100, or say $1,000, and yeah, and pay for uh, Sunday was say I would say how much, $20,000. Okay, then yeah, so it is a simple to sorry. Correcting. Let's keep it 20,000. Let's keep it 1,000. Yeah, so you may say that hey Aditya, what is happening is on Friday we are having a good amount of sale, and in Sunday we are not having any sale. So this thing is kind of not intuitive. So when you because of this samples, because on Friday we are having we are having 100 observations or samples. I mean the observations only, and on Sunday we are having 10 observations. So yeah, so that kind of brings in a bias. So what we do is we just divide this by 100. So we will get $200, and for $1,000 we will get around $100. Yeah, so it is still consistent with the result, but yeah, but sometimes it will get more. Sometimes it may bring up a bad thing. For example, if I use say $2,000, then it will be $20. So we can say that on Friday we are having a $20, which is kind of bad thing, and on Sunday we are having 100. But if you see on the overall, Friday is 2,000, which is more than Sunday, which is $1,000. Okay. So this thing can create a bias. This thing creates a bias. Okay, creates a bias. This is a very statistical term, or I would say you can say some abnormality here. So what we do is we try to reduce this by introducing this term called scale. So a scale basically means how you want to scale your data. So here they have used the option of count. Okay, so yeah, so that's why this has got scaled by the count. But yeah, but we can have other observations. One thing you can do is you can just simply divide the term with a constant. Simply divide the term with a constant. Okay, so you can say like for Friday, let's divide the term by say 100, and for Sunday let's divide the term by say 10. Yeah, so it can be it also depends on the user, or like the person who want to scale it. So one way of scaling is this. Okay, this is a one way of scaling, I would say, ways of scaling. Okay, one way of scaling is this. Another way of scaling is which we call the min-max normalization. I think I will not go into that much details. We have two more. One is min-max, and third one is simple standardization. So yeah, so these two are the terms. Standardization is mostly used for Gaussian distributed terms, but Gaussian distributed terms are mostly used for Gaussian. Yeah, but yeah, you can ignore these two things. Okay, we don't need this. Yeah, this is kind of a simple thing, and we also use this divided by the count. So when you are taking the count, so what you are trying to do is you are just doing yes, so it's simple enough. You are dividing it by count. I will not go into much in depth in this case. So yeah, so it will just make a graph out here. So yeah, let's actually compare the graph. Okay. Okay, so let's actually compare the graph. So as you can see, this orange one, so we are having this something like this, and when we do the scaling, it is getting contracted. And yeah, most of the things remains the same. And yeah, and most of the things remains the same, but for this orange one, it is getting a contracted, and this Thursday one is also getting contracted by some amount. And yeah, okay, so these are the things, but most of the thing remains the same. Okay, for example, Saturday one, it remains the same. Okay, so yeah, as you can see, it is mentioned that to make the broadness of each violin proportional to a number of counts. So yeah, as you decrease the value, then it will automatically the size will decrease. Okay. Oh, so any doubts? Okay, so we can just finish this violin plot first. Yeah, so we have this violin plot actually. In this violin plot, what these guys are doing is, we don't want this line. Okay, instead of making this line, what you can do is you can just simply make the quartiles out here. So this upper line is the third quartile. This this middle line is the what do you call this median, and this last line is the first quartile. So yeah, so as you can see in the code as well, so this inner, so if you try to parameterize this inner parameter, like if you give an value to this inner parameter, so this will be a quartile, or you want to say that make it by quartile. Okay, so yeah, dot SNS of quartile. Okay, so quartile thing works. And if you want to make the points, the data points out here, so you can also use the data points thing as well. If you want to make quartile and the data points both, then just try to plot both the plots in the same canvas, so you can get the points as well as the quartiles as well. Okay, what we are changing is, this is the inner parameter, we are just changing it to point. So you can also Google this thing, what's an inner parameter. So you can just go here and see what's the inner parameters. So it has a bunch of parameters. So you can see it will represent the data points in a violin interior. Okay, what is the function of box? Draw the miniature box plot. If quartiles, draw the quartiles of the distribution. If point is stick, draw this, and none, then it will just ignore it. Okay. Scale is also used to scale the width. Yeah, mostly used to scale the width. So I would say you guys don't go into these much details. Okay, you can ignore this for now. Okay, these are actually the benefits of doing the scaling, but yeah, but you can ignore this. The main thing to remember is that scaling simply reduces the scales the width of the violin. So this is the violin width, this is the violin width, and we are just changing the violin width. Okay, that's all this thing is doing. Okay, and we have a bunch of parameters, like how you want to use the scale. So yeah. Okay. Okay. So yeah, so what you can do is, yeah, so you should also always don't go into much details, because it might hurt your understanding. So best is to stick with the basic codes and all these things. I also don't know like all the parameters out here. These are I don't know how many parameters. These are I think 10 to 11 parameters. Yeah, I think no human can learn all these parameters. So what you do is you just Google the what do you say, this function, and then take all the like important things or the necessary things from this documentation. Okay. All right, so this is the thing. I'm not sure. Yeah, we cannot run this actually. Okay, so yeah, so this is the thing. You can also make this double violin plots. How will you make this double violin plots? We can use the parameter called hue. This is the hue, and how you want to make the violin plot. So we want to make it on the basis of sex. Okay, so in this case, you can see the sex, and we have this a blue one for male and the orange one for female, and yeah, and in that sense, you can make two or more depending on the possible values of the sorry, yeah, depending on the possible values of the parameter. So here, sex is having two categories. Okay, categories. I think it's the correct spelling. One is male and female. So using hue, it will make I would say two violin plots for each value of x-axis. What's the value of x-axis? It's the days. Okay, weekdays. Sorry, not the weekdays. It's the days only. And yeah, and it will make two parameters. Why two? Because it sex has only two categories. Okay. If you let's see if we have some other categories out here. Let's see. Okay, sex is done. Yeah, we have something called smoker. I don't know how much parameter the smoker has. Let's see. So if you do something like this, so yeah, so we have two types of smoker, one who smokes and one who does not smokes. That's kind of intuitive. So we will get two here. Let's go with time actually. I think time will have four. So you will get four plots. Let's see. Okay, so we have two parameters in time, that is lunch and dinner. I don't think we will have much here. So yeah. Or yeah, let's see, let's change this to time here. And I would say let's change this hue to day. Then see what will happen. Okay, this is too much. Yeah, so as you can see for the lunch, yeah, so we have two, for time we have two values. One is the lunch and another is the dinner thing. So yeah, as you can see for dinner, we will have four categories: Thursday, Friday, Saturday, Sunday for the day one. So we will have four, but for lunch, we don't have the observations for Saturday and Sunday. That's why there are no plots. And for dinner, we don't have the observation for Thursday. That's why we are not having this plot. Okay. Okay, so these things are kind of simple actually. So yeah. What time? What was this? Okay, so you can also play around with these things as well. Okay. Yeah, you can also merge this thing. How will you merge this? You just add a parameter called a split. So by default, we don't have a values for split, but you can add a values for, sorry, not try. Yeah, you can. So that's for the aesthetics or the beauty of these graphs. So yeah, you can use all these, fun stuffs in Seaborn. Okay. Alright, yeah. So now we will be dealing more with the beauty of the plots or how we can make a plot beautiful and all these things. So yeah, any doubts till now? Any question? Any queries? Like going once, going twice. Okay, I don't think we have any doubts. Okay, all right. Yeah, let's try to understand this code actually. What is the set style? SNS.set style. So we have a bunch of styles in Seaborn. Okay, we have a bunch of styles and we have a bunch of contexts. Okay, so I really don't know the like the meaning of this style and this thing. So what you can do is you can just type it here. and it will just give you the things. So yeah, so it will give the general style of the plots as I was expecting, and controls the properties such as the color of the background or whether the grid is enabled by default. So we can also have these grids in the plots. So you will have this some vertical lines and some horizontal lines. So you can make these things, okay, like this one. So these things are called the grids, and this I would say this canvas. So we can place a particular background to this canvas. For example, in this case, so we have the grids and we have the canvas, which is, and the background of this canvas is gray. So you can make this a gray color. Okay. Yeah. So by default, we have a bunch of styles. For example, in this code, they have used the a white background, and we can have other styles as well. Okay. This is something called context. So yeah, let's check this out as well. We'll deal with the context thing. Yeah, it will do the scaling of the plot elements. Okay, control the scaling of the plot elements. So yeah, it will just make this beautiful or something. Yeah, not yeah, it will just try to change the size of the labels, lines, other elements of the plot, but not the overall what do you say? The overall background of the plot. Okay, so it will not affect that. It will just affect the elements of this plot, like this lines and all these things. So yeah, so you can actually make your graph a bit beautiful. So yeah, so as you can see, you can make a bit this more darker, or if you want to emphasize something in the plot, then yeah, you can also use this thing. So yeah, so that is, so first command is for the whole background, and a second thing is for the elements of this plot. Okay, next is the same thing. Okay, next is the same thing, axis. So we are just making the plots. Okay, I think, yeah, we are not doing anything. So I think I have taught you this box plot, strip plot, and all these things. Yeah, and you can just change this face color as well. I don't like this tuple like thing. Yeah, I think you guys will get confused with this tuple like thing. So best is to write a simple color, so gray, blue, black, or something. And yeah, and we have this strip plot out here. So yeah, that's for the plotting purpose. Plotting purpose. Next we have the labels. We call this as the label. So you can write the labels.
One
So
question.
yeah, sure. Please ask.
About the box plot where we indicate the color, yeah, I don't understand why we give these number values. But when I indicate white, it's really the same. I don't see any difference between just writing white and that numbers 1110.
Okay, so
I tried to change all the ones into zeros, and it was the same image, like it was white. I tried to change everything to 1, and it was still the same. I couldn't find what does this do. Really.
yeah, I also I am also not sure what this do. One I think you are making a very small change because you are just changing ones and twos. Yeah, let's make it okay. RGB values. Okay, this is the RGB value. Okay, all right.
From 0
Okay.
to 1.
I got it. Okay, so we have something called RGB.
No, I know RGB. Or everything is clear now.
Yeah. Okay. Good. Yeah, for others as well, I can just tell them the others. So we have something called RGBA. I'm not sure what's the full form of RGBA. A is, I guess, red, green, blue components. RGB, I know. I'm not sure about, yeah. Oh, okay. A is the alpha. Okay. All right. So we have something called red. We have something called green. We have something called blue. And we have something called alpha. Okay. Red color is the red color. So the thing is, every color in nature, okay, can be represented by by some values in R, comma G, comma B. Okay. Okay. So that's one rule. And alpha is the opacity. Okay. Alpha is the opacity. So yeah, so we have two rules here. So first is that every color in nature can be represented by a particular value in R, G, and B, and we have something called opacity, which is called the alpha. Okay, so yeah, so you don't have to go into much details. I will just show you an app here. Let's go with the color picker. Sorry, Google color picker. So as you can see, this RGB thing, right? So for this color blue, so you can see that this is 66, 130, R's value is 66, G value is 132, and B's value is 245. So this R value, yeah, so this R value, R comma G comma B. So these values will lie between, 0 to 255, or you can say 0 to 1. Okay, so these both things are the same. So if you have something called, say, RGB is equal to, say, 245 to not say 240, 245, or 255. So yeah, so as you can see, these are all in the 0 to 255 range. So how will you change it to 1? Yeah, just divide it by 255. So what will you get is 240 by 255. Okay, and 245 by 255, and 255 by 255. Okay, so these are the values between 0 and 1. So you can get this thing in 0 and 1. Okay, you have the color value. So if you change the color, then this RGB values will change actually. Okay, yeah, so every color in nature can be represented by a particular value in R, G, and V. These RGB are also called the channels of a color, but yeah, but you can ignore all these details. You will not need this. If you're taking a course in image processing in future, then it will work. But yeah, so this value is the RGB value. When you have R, G, and B all as 255, or I would say 1, then it's a white color, and this 0 is the basically the opacity of this color. Okay, or the
Yeah,
alpha value.
thank you very much.
Yeah. Okay. Okay, so this thing has got hanged, I guess. Okay, this thing has got hanged somehow. We will come back to this practice session. So yeah, so this is the thing. So we are labeling X and Y, and SNS dot define, so it will just make the plot. Okay. Okay, something happened up there. Okay. Yeah, so that's the basic thing of this. Okay, so let's wait. Yeah, it is just write the labels, and SNS dot define is for making the plot on the canvas. Okay, that's the simple thing. You can also Google it, like if you want to SNS.despine. Okay. Yeah. Okay. It remove the spines from the right. Yeah. It like it is not very much used out here. So yeah, I don't think you can ignore these things. Okay. So if you plot this, so you will get this. Okay. And if you remove this, then also you can check if something is getting removed. Yeah. So this thing I think is called the spine, I guess. D spine is removed. Yeah. Yeah, okay, so maybe I can just change it. Removing the spines. What are spines? Unnecessary text. Okay, it is mainly for this use. In Matplotlib, we have something called we have something called plt.plot. So this also does the same thing. Okay. Okay. Yeah. All right. So yeah, that's the aesthetics of this plots or the combined plots. Okay. Yeah, same thing goes here. You are just changing the style. You are just changing the context. This is just the violin plot. Just a simple violin plot. You are just labeling it. You are removing the unnecessary text, and yeah, and that's all. Okay. So I think you can just go over this once. Yeah, most of the things you are doing is just repetitive tasks. Yeah, most of these things are repetitive. Okay. So what you are doing is, yeah, let me just break this down the code for you. So one is the for styles. Okay, this part of the code is for the styles. So what you can do, like for making your plot, you don't have to change this thing. Okay, you don't have to change this. What you have to change is this command. Change this command. Why you want to change this command? Like how will you change this command? Depending on your plot. Okay, if you want a violin plot, then write SNS.violin plot. If you want to make a box plot, then write box plot. If you want to make a bar plot, then write bar plot. Okay, so change this command depending on these things, and change this if the labels. Yeah, change this if the x and y axis are changed. Axes are changed. Okay, and sorry, and it is for removing any unnecessary text. What's the spelling? Or I would say spine. Okay, so yeah, that's all for this. And yeah, and same you can do some other context. Yeah, we have something called notebook constraint, paper constraint, paper something, talk. Yeah, you can just Google all this stuff, but yeah, at the end of the day, it is just a simple thing. Okay.
A question, a small question. So it means that we keep our plot as a variable, yes, an x, and then we can add to this an x2 already new functions like set. Yes, so instead of so we keep our plot as an object, yes, an x2, and then to this object we already can add new functions.
Yes.
Yes, something. And then okay, then I will ask later. Okay.
Yeah, so you can see that
So
we are having an access, so we will make one plot, and yeah, and we are again adding another plot. So how will you add this? You just change the variable with this thing, so it will work. Okay.
Yeah.
But can we put into one category like when we are making combined images like this one with two box plot and three plot? Can we make it into a one variable only?
Okay, so you want to make this into a one variable, right?
Yes. Can we do
that? Yeah, actually we can't do that because these two are very different functions. Okay. So yeah, so variable actually won't work. Yeah, but actually if you want to change this variable to this one, then it will actually make, yeah, so you will have to make another right, something like this. You will have to change this thing, and yeah, so that's why we always use a single variable out here. But if you want to write these two commands into a one command, then it will not work. Why it will not work? Because we are working with two functions which are very different from each other.
Okay. But if we use the same name for both of them, when we will recall the axis variable, it will show the combined picture.
Can you repeat your question?
If we give both plots the axis, just axis, not axis one,
just
name,
axis,
axis, and we recall the axis to be shown, then it will show the combined plots.
Okay, so you mean to say that if I change this to axis, right?
If they are both axes, it will be like one variable containing them both.
Yeah. So it will be having both the plots in this axis thing.
Okay.
Yeah. So why do we do like we do in this fashion? Because we in most of the cases we work with 2 or 3 plots on the same thing. So yeah, we have a concept called subplots. So in that subplots as well, what we do is we make one graph here, one graph, like one graph here, one graph here, in that sense. Okay. So yeah, at that time it will be helpful for you guys. I don't think Sergey has taught you subplots. I don't remember exactly. Yeah, we have something called subplots. So this is sorry. This is called the subplots. One plot is here, another plot is here, this plot is here, this plot is. So we are working with 4 plots, right? So if you change the variables, so in this case we are having only 2 plots, so we can just say axis 1, and you can just change the parameters of axis and axis 1. But if you want to change the parameters of all the 4 plots at the same time, so what we can do is you can just make one variable and then change this variable like this thing, and we can just remove this one. Yeah, you can just change this variable like this, and yeah, and it will work. I think that reduces some of our work, and yeah, and it makes our code look more cogent. Okay.
Okay, thank you very much.
Yeah, and if you want to return to your default settings, yeah, just reset ORIC, just write this function. Okay. Yeah, so it just write this function. Nothing much. So it is used as a flushing command. Sorry, we have a something called flush command. Yeah, in Python. So it basically runs this thing. It just flushes all the plots. Okay. All right. So yeah, so we can now work with this thing. So yeah, let me write the two what do you say, two functions, both of these functions, and then I will show you what these guys are doing out here. Okay. Okay, let's first work with this two. All right. So you can see two functions. One is sns.barplot. You are giving the data, you are giving the labels, and you are giving this order. Okay. I think this is not a label. We can call this a column, but yeah, you can ignore this thing. Yeah. So we can give the order of this, like in which order you want to plot this. So Friday, Thursday, Saturday, Sunday, Friday, Thursday, Saturday, Saturday, Sunday. I am not interested in this. So what will I do is I will just plot the Sunday first and then the Friday one. Okay. So you can change this order as well. Okay. What you can see is we are just placing the order and we are just giving the list out here. Okay. Okay, we are just giving the list here for an order thing. Okay. We can do one more thing. We can just initialize a variable with this list. Okay, and pass this variable as a parameter to this function, which is sns.barplot. Okay. Have you understood this thing? You can just make a variable and pass this as the order. What will it do is it will just just make your code less clumsy, I would say, and clumsy, and you can reuse this stuff again and again. Okay. Okay, so yeah, that's a simple thing. So you don't have to, we can make orders, I would say. We can place an order. Okay, which letter is this? I'm not sure. Yeah. Okay. Yeah, and if you want to remove this rubbish stuff, so you can just write sns.just fine. do we have this brackets? Okay, yeah, these brackets. Okay. So it will just remove this thing. Okay. All right. So yeah, let's go with this next one. Okay. Yeah, it's the same hue thing again. So yeah, what it is showing that. So I have told you about hue, like, right? So what is hue? So we can make multiple plots. I think in this case only. So we can use multiple plots. Yeah, let me just remove this stuff. Okay. Yeah, something has got wrong actually. Yeah. All right. So what is being done is, yeah. So when you add the hue, so for each of the category of sex, so they will make the violin plots. Okay. What you can do is, you can also initialize a variable out here, and you can change the order of this thing. So here you can see first is male, next is female, right? And if you want to present it in this fashion, say first is female, then is male, then you can always add an order out here, which is given by this parameter hue order. So you can just give a variable which is given in this fashion. So in this case, we are using the days as a parameter. Okay. So yeah, and in the earlier case, we were using the sex as a parameter. So like if you want to really want to do this out here, so you can do is hue order, and what's the order? So you can use female and male. Okay, and it will just change the color. Okay, something got wrong. Okay, some name has got wrong. I guess. Let me just check it out. Hue order has got okay. Something has got wrong out here. Don't know. Yeah, I think something has got wrong here. I'm not sure. Yeah, we can also check this out here. Yeah, so for 6 and yeah, for day, let's keep it with day. And yeah, and we put this as female, then male. Okay, I'm not sure why are we getting completely white thing in this case. Yeah, we have to check this actually. I'm not sure. Okay, so I will have to check this. Why is it not coming in this order? Hue order should give this an order actually. Yeah, as far as I remember, it should give an order. I'm not sure why is it deleting it. SNS dot box. Hue order. Step string also order to plot the category labels order-wise the labels on the data objects. Okay, I'm not sure why is it not working out here. Yeah, basically hue order, as you can see, it gives an order to the values. Okay, so Friday, Thursday, Saturday, Sunday. So first thing will be of Friday, next thing will be of Thursday, next will be of Saturday, and the last will be of a Sunday, right? So yeah, in that sense, it will just give the order of this. Nothing much to do. Okay, so yeah, let's move ahead with this. I will just check this out. Why is the female male not working? Yeah, I am actually not sure. Yeah, I will just check you and let you know. I will mail you regarding this. By the way, do you have a common mail ID?
For all the students, I don't think so.
Okay. I think someone was preparing it. That's what I heard from Sergey, but yeah. I think it's a better thing to, a good thing to make a mail ID, a common mail ID, so that we can just put in more resources, and yeah, and if you have some doubt or something, yeah, you can just put in down there. Okay. So yeah, I will just check this out, what this thing is, and yeah, and I will just let you know. All right. Yeah, next is the color palette. So as you can see, we are having these colors. So you can also change the colors of this. Okay. If you want to make it red and of some other color, like in this we are making it violet, and I don't know which color is this, and this is grayish color. So yeah, you can also change this. So what is the function? You can use the palette function. Okay, what's in palette, by the way? Let me just tell you what's a palette. Yeah, if you want to see this, so this is an palette. So what's a palette? So you can see that we are having a bunch of colors here. So yeah, that's the palette. Okay, what we do is we just take the color and then paint it, right? So yeah, same thing is being done here. So yeah, so for this palette, so you will have to tell which parameter will go with which so yeah, so you will have to tell the code that not what I would say compiler, but anyways, yeah, tell the code that which color will go with which parameter. Okay, so how will you tell this? So you will tell this using a dictionary. So for Thursday you will use a purple color. For Friday you will for Friday you will use orange. For Saturday you will use brown. For Sunday you will use gray. And there are a bunch of other colors as well. So if you want to use blue, then you can use blue. And I think there was another color called lime green. So you can also use lime green. Okay, so you can just play around with this, and what will you do is you will just pass this color dict into this palette parameter, and yeah, and it will just make a plot with that. Okay, yeah, so you can also get the bunch of colors out here. So yeah, so this is the list of colors. I don't know where is the color list. Yeah, these are all the colors which are available for Seaborn. Yeah, as I said, yeah, like a Seaborn library is based on this matplotlib. So the internal functions of the Seaborns are based on this matplotlib only. Okay, yeah, that's why this colors is redirecting to the matplotlib documentation. Okay, yeah, but you can ignore this thing. So if you want to see a list of colors, then just click this link and you will get the bunch of colors. Okay, I think these things are pretty much simple, I guess. Yeah, and we have something called relational data set. So what's relational data set? Okay, how much is left actually? What's a relational data set? So some of the parameters are dependent on the other parameters. Okay, that's like it is having a kind of relation with other parameters. So yeah, so just like the earlier one, so earlier we were working with categorical data sets. So here we will be working with the relational data. What's the name of the data? It is MPG. MPG is regarding the miles per gallon, or I would say how much oil is it consuming, a particular vehicle is consuming, I guess. Yeah, I think that's the thing. So we are having a vehicle name. This is the vehicle name, Chevrolet something. Chevrolet Seville Malibu. Yeah, let's see this car, by the way. Which car is this? Yeah, so you can just Google this car out here. Yeah, this is an old car, I would say. Yeah, this is an old car, and if you want to see some other cars out well, so for each of these cars, so they have calculated the mileage actually. Okay, so they have calculated the mileage. So These are a bunch of, I guess, old cars, I guess. Yeah. So these are a bunch of old cars. This is the MPG and cylinders, how much cylinder it requires, displacement, how much distance it has traveled, horsepower. Horsepower, I think we all know, weight of the car, acceleration of the car, model year. Model year is 1970s. So yeah, as you can see, these are all old cars and origin is US. Okay. This is a simple data sort, data plot. So we have something called line plot. What would the line plot do? Yeah, so what will the line plot do? It will just make a line. That's all. Yeah, it will just make a line. Make a line based on two parameters. Okay, so it will just make a line. So it will just take an X parameter and a Y parameter, and yeah, and it will just make a line. So these things are for the beautification purpose, but the main idea is with this darker line. Okay, so this is a darker line. Yeah, so it will just make a line. So you can say that for a model year of 1972, what's the mileage per gallon, or I would say what's the mileage? So this is miles per gallon. Okay, so 72. So you can create it at around 18 or 19, I guess. Yeah, for a model year of 72, so you will get a mileage around 19 or 18. So yeah, that's the information which is given by a line plot. Yeah, this is a kind of error. Yeah, so I think this bunch of things is called the error line. Okay, how much error is there? Okay, so yeah, I am also not sure why is this error coming out. Yeah, they have also not mentioned it. So you can, yeah, instead of this continuous light color, you can just make some lines out here. How will you make some lines? You will just have to write a new parameter which is air style. Air style is equal to bars. Okay, air style is equal to bars. And if you want to see some other parameters, so what will you do is you will just simply check this out. Okay, you will just simply check this out and check the documentation, and it will tell you each and everything. Alright, let's see which one is it. Error style, error style. So let's find this out. Error style. Where is error style? Yeah, so we have this band. So we are getting a band of something, and in this we are getting a bars. Okay, we have to draw the confidence intervals for transfer to color. So it will just draw the confidence intervals or something. I am not sure how they are calculating it, but yeah, I also don't know the formula of this calculation. How are these guys calculating this thing? Okay. Anyway, so yeah, so this is the line plot. Okay, we have something called a scatter plot. You don't have to do anything. Just write this scatter here and remove this error style because we don't have any error in here. Okay. Yeah, and just make a plot of this. Okay, this thing is different. Okay, so yeah, so why is this like this? Because we are working with this working with the categorical variable. As you can see, this model here is a categorical variable, and it will run from around 1970 to 1982. Okay, this here is a categorical variable. Okay, and this will run from 1970 to 1982. For scatter plots, yeah, we don't work with the categorical variable. We work with the normal variables, or which is or I would say a continuous variable. Okay, so that's why it is kind of continuous. Okay, so you can also Google. So I think you guys know what's a categorical variable and a continuous variable, right? I hope you guys know this type of things. Yeah, continuous and categorical. I hope you guys know what's a categorical variable and continuous variable. So a scatter plots are mainly done for the for the continuous variables, and line plots I think are done for both categorical and continuous in this case, we are doing it for categorical variables. Okay. Or you can use different color code as well. Okay. Yeah, you can use different color code. So by using hue parameter, you can use different color coding. So we are having a different color coding for each of the, like the origin parameter or something like this, origin where the car has been like made or something. So yeah, so we have three categories: US, Japan, and Europe. For each of these categories, so we are using a different color. Okay, and yeah, and yeah, you can also use the represent this by the size of the thing. I would say size of the dots. So you can also change the size of the dots. So what parameter does the dots have? So basically dots have two parameters. One is color and another is size. Okay, so you can change both of these parameters, color and size. Okay, for changing the color, you will put this hue parameter. For changing the size, you will use the size parameter. Okay. Okay, for the size parameter, you will have to put a what do you say, a continuous variable. Okay, size will always take a continuous variable. Okay, and color will always take a categorical variable. Category, yeah, you can just take note that. Yeah. So yeah, that's what is this thing is doing out here. Okay. And these are some basic stuff. You can also plot the matrix. Yeah, so okay, we are again returning to categorical data here. So yeah, so we are again working with a data called flights. Okay, this is a third type of data. We are working with the flights data set. So yeah, let's see what is this happening. Yeah, so we have the year, we have the month, and we have the passenger. So it is saying that for which month and which year, how many passengers have traveled. I think that's the basic idea of this data set. Yeah, and you can prepare the pivot and all these things. Pivot will tell you, yes, it will basically make a matrix out here. So for each of the month, so what are the possible month? I would say let's see the total data actually. Yeah, so how many months are there? We are having 12 months, and how many years are there? So these are the years from 1949 to 1960. Yeah, so for each of the year and month combination, how many passengers have traveled? So that's what the pivot does. Okay. So yeah, so actually this pivot is from the pandas. So pandas.pivot. So you can also see how these, yeah, how this is making a pivot out here. But this documentation is empty. It's kind of strange. Okay, sorry, this is, yeah, it is below. Yeah, so we are working with pivot actually, not pivot table. So yeah, so pivot will actually, sorry, how long is this? Yeah. Pivot will return a reshaped data frame organized by a given index or a column values. Okay. Yeah, that's the target of the pivot actually. So for each of the possible years and each of the possible months, so it will tell you how many passengers are there. So for each of the possible month and year, and if you replace this year and month out here, then it will just change this thing. Okay. Or I would say it will just take the transpose of this matrix. So I hope you know the meaning of transpose. Okay. So yeah, if you change these parameters out here, then it will just, or if you replace this, then it will just change the transpose of this. You have something called heat map. So you can always make a heat map of this. Heat map will basically place a color based on the range. Okay. So what will heat map do? So heat map, yes. Yeah, so we have a range of colors. Like if the value is low, then we will have a dark color. And when the value is high, so we will have a light color. So yeah, so it is just like instead of writing 204, it is just giving a color out here. Okay, that's the heat map. Okay, you can also use this annotation. So what will this annotation do? So you can see we don't have anything mentioned here in this boxes, in the small boxes, right? If you want to add the value in this small boxes, then you can just make this annotation is equal to true, then this will add the values out here. But it is kind of weird because everything is coinciding with each other. So yeah, that's a bad thing. But you can do this thing. Okay. Yeah, you can have a bunch of other parameters like you can use decimals. So we are having this in the exponential form, right? So you can use the decimal form. So you just add another parameter called fmt and just write d here, and it will give the decimal value and uh, not the numbers after the decimal. Okay, yeah, and you can choose a bunch of color mapping. So this is the default color mapping. So there is another color mapping called cool warm. Okay, so yeah, so you can just change this, so it will just change the color. Okay, it will just change the color. For 200 you will get a light color or something like bluish type, and for high value you will get a red color. So we have a bunch of C maps here, so you can just Google it. How will you check this out? So write sns.heatmap, so it will give the documentation and you can view it. Okay, you can view these things, C map and all these things. C map is a color map. Okay. Okay, so yeah, so it will give this type of heat maps and all these things. We can have beautiful so we can add something related to this flash.pivot this. Yeah, we can add this annotation is equal to true with fmt is decimal, so it will only give the decimal values. And yes, same is, yeah, we can add the lines in here, so line widths, and we can just add something else. So yellow, green, blue, so this is another type of C map or color map. So yeah, you can use this as well. We have another type of color maps. Yeah, you can also work with these things. Okay. Yeah, I think we are at the end of this. So yeah, so you can save this thing. Okay, so let me just yeah, so you can write plt.savefig or something. Okay, so you will have to import the matplotlib for saving the data set. I don't think these guys have the saving plots with Seaborn. Let's see if these guys have save plot Seaborn. No, these guys don't have to. Yeah, these guys don't have anything. Yeah, so these guys don't have a particular function for saving it. So what we do is we will import another library called matplotlib. Okay, matplotlib, and we will just save this figure. Okay, so so this file is not there in my account, so because I have not imported the drive. So yeah, so for the drive, first you will have to mount your drive using collab. Mount your drive to collab. So So it will ask your personal details like password and all these things. So you will have to provide those details. So it will ask your Gmail password, username. Yes, it will ask your password and Gmail password and username, and you can then so the first thing is to mount the drive to your collab. Okay, first thing is to mount the drive. Next is to import this library called matplotlib. Okay, and then you can save this file. Yeah, and yeah, as Sergey said at the end of the lecture, that some portion can be cut out. So yeah, you can use this parameter b box inches is equal to tight. Okay. Okay,
excuse me, a question. And where I need to write which plot I'm going to save? Yes, because by default I will save a blank plot as a PDF file. But how to say, for example, the last plot that was produced for this heat map, for example?
It is always the last plot which is saved. So
it is always the last because I tried and it seems to be it is not the last.
Yeah, let's see. So
because
if I save this out.
You have, okay. So the last plot that was produced on the screen, yes, will be saved on your drive.
Yeah, so in this case, yeah, so it is not giving anything. Yeah, so we can
it's empty also.
Yeah, so we can give it to a PNG, I guess. Yeah, let's see. Yeah, I think it should always. Something. Okay, so so it appears that it will save an empty because we haven't mentioned anything.
Yes, but where to mention which plot to save? I think you need to name somehow this plot as an object. I don't know.
Yeah, I got your question actually.
Okay.
So yeah, so the problem is why is it not saving it, right? Yeah, so basically what we do is we import the matplotlib, and before saving the plot, we do this thing. We put the sns.heatmap, and then we do something called plt.show out here. And then we save this plot. Let's see what happens next. Okay, this is not saving anything. This is a weird thing which is happening out here. Plt dot. Save the current figure. Plt.base, yeah, matplotlib saves the current figure, as I told you, saves the current figure. But for some reason it is not there. This gives blank image.
Okay. Before plot show. So this plot show, it means after plot saving, not?
Yeah, I also think so. So let's do it. Yeah, so before printing the plot, yeah, if we do this thing, let's see if it works out. Yeah, it works. So yeah, so the basic rule is
great.
Yeah. So for saving the file, I think I should change it, or no, let's this for saving the file, one should I would say one should plot it after saving it. That's an incorrect English, but yeah, but I think you have got the idea of this. So yeah, one should after, otherwise it will get flushed. Okay. So yeah, so if you plot this before this before saving the file, so what will it do is, so it will just flush the file. So yeah, that's a bad thing. Okay, that's a bad thing. So what thing? Yes, yes. So what is the correct way? So before displaying the plot, uh, you should always save it. Okay. Yeah, you should also always save it. So this, yeah, this piece of code is wrong actually. This will not save anything. Yeah, I will talk to Cynthia. So yeah, this piece of code is wrong.
Just to add one line, yes, plot show, PLT show.
Yeah. So actually, you can also remove that show stuff. So yeah, so the basic concept is like before showing or something, yeah, just remove it, because in this case you are not typing the plt.show command, but yeah, but it is still showing it. So yeah, so it is an inbuilt function in what do you say, this Seaborn stuff. So yeah, so before just directly showing the plot on this canvas, so you can, yeah, so you will have to first save it and then show it. Okay, that's the basic thing. Okay. Yeah, one should plot it after saving it. Yeah. All right. Okay. Yeah. That was a good question. Okay. So we are working with the next step, which is the assignment. So yeah, so you will have to make a bunch of plots out here. Okay. Yeah. So it should look something like this, and this. Okay. So yeah, so we will be, yeah, so you guys will be working with the Titanic data set. It's a very common data set, and yeah, and mostly we use this data set for machine learning tasks, but you will be working with the plotting stuff. Okay. So yeah, so you will have to make a bunch of plots, I guess. Yeah, you will have to make a bar plot or and make some style changes in this, and in this case you will have to make this box plot and the strip plot. Okay. For the third one, you will have to make some other type of, which is this. Yeah, I think you will have to make the violin plot. For the fourth one, you will have to, yeah, do a bunch of more stuff, I guess. What is this? This is, I think, the scatter plot. So you are trying to make a scatter plot out here. Yeah, I think this is yeah. So it is a scatter plot. Okay. And yeah, for the last one, yeah, this is the heat map, and you are using the annotations and all. Okay. And for the last one, yeah, I think you will have to save these files actually. You should get these as the output files. Okay. You should get something like this stuff.
And we need to put this file together in one? Because
yeah, so
you
you
mentioned at some time about subgroups, so when you can place a few plots in one file.
Right. So
something like that at the end, I think.
Yeah, so we have something called a subplots as well. So where you can make a single plot in which all the plots are present. But yeah, but in this case, you can make, multiple plots and then add it in a folder and then add it in the drive. So that will also work. Yeah, I don't think these guys have taught you the a subplot thing. So we have.
No, we didn't speak about subplots, but just mentioned.
Okay, yeah. So basically, we can do something called subplots out here. So subplots are done by this matplotlib stuff. So yeah, you can just use this subplots, and I also don't remember the exact function of subplots. So subplots in Python. Let me just show you a quick link, and yeah, and then you guys can work on this. Okay, so we have something called subplots. So in one plot, so this is only one plot out here. This is only one plot, but you can go for multiple plots. One such case is, yeah, this is also a single plot, and yeah, what you do is, First you will have to use this command actually. This will ask for sign in and all these things. Yeah, plt.subplots. You will have to give 2 by 2. Okay, so it will give 2 plots by 2 plots. Okay, that's what it is called, 2 by 2. Okay, 2 by 2 plots. So it means that we will have 2 plots in column and in 2 plots in the row. So which will give us 4 plots actually. So it's kind of a matrix, right? 2 by 2 matrix, or I would say 4 by 4 matrix. So in that sense, and this is, yeah, so you can ignore this thing. And yeah, what will it do is, so it will give you a particular positions out here, and this particular position is given by this axis. So yeah, so you can give ax00, which is the first plot, as plot x comma y. Okay, which is actually a line plot in the sense of matplotlib. And we have something called ax11, then it will give me the scatter plot out here. Okay, so yeah, let me just do it. Sorry, what just happened? Okay, wait for a few minutes. Yeah. So yeah, so what we do is fig.axs. Okay, so plt.subplots. Okay, and then we get this axis stuff. So let's make a, yeah, so let's make a 2 by 1 plot. Okay, now so we will get a 2 by 1 plot. So it will be like how will be it? So 2 by 1, so it will be something like this. So we will have one plot here and we will have another plot here, like top bottom plot in that sense, right? So 0 comma 0, which is the first plot. So in this plot we will, yeah, so we can make, say, let's say, yeah, so let's plot this one. Okay, yeah, so let's plot this one. And yeah, and for the next one I would say 0 comma 1 actually, and let's plot something else. Yeah, something else. And we can put all this title and all this stuff later, and we can just say plt.fig.show. Yeah, fig.show also works, but plt.show will also work. So yeah, let's plot this. Matrix data not defined. Okay, yeah. Okay, so this has lost the runtime. Okay, let's go with the second. So okay, so the runtime has got disconnected in there. Yeah, let me show it here actually. Where is the subplot? Yeah. So yeah, and if we run this function, so too many indices, too many index. Okay, I think this will be the one dimensional and two were indexed. I am not sure about this. Why is this happening, by the way? Yeah, there is some issue with this thing. So
Maybe 0, 1, and then 1, 0. I don't know, because 0, 0, it means...
yeah, 0, 0 is the first one.
It's
0,
the first. Uh-huh.
yeah, so we can put it, no, 0, 1 will not work actually. Yeah, there is some indexing issue with this. Yeah, this first one is not getting printed first. Yeah, cool bomb is getting yeah, it should actually work out here, but I'm not sure why is it not working. I will have to check with this as well. I am not sure actually. One the scatter plot and 2 by 2 square. I'm not sure it should work actually. Anyways, I will just take a look at this. Yeah, I think this is a size issue or what. Yes, it should actually work. Line and period. Oh, yes. So this is some issue with the indexing of this. So I will have to look at, yeah. I don't remember the indexing, how they have used the indexing of it. Yeah, I will have to take a look at this. Yes, I will have to take a look. Okay. Yeah, this is the thing. All right. So basically, what happened is, sorry, where was the command? Yeah. So there was actually an issue with the indexing of this. So when you are typing 2:1, then yeah, so we will have only two indexes, two indices, which is 0 and 1 only. Okay, yeah, that's why it was showing an error out here. Okay, in that earlier case we were having 4, so yeah, that's what the issue is. But you can also change the size and the shape of this. Yeah, you can also change the size and the shape, because of this is not getting printed properly. So yeah, so we can change it by fixed size, plt.fixed size and all those things. So yeah. Okay. All right. So this is the plot actually. So yeah, so your task is to not to make the subplots and all. So yeah. So you will do, yeah, so you are not asked to, kind of make the subplots or anything like that. So yeah, for your assignment, I think it is kind of simple. So you can go over the assignment, and if you have any doubts or something, so we can handle it. Okay.
Yes,
Yeah,
we will just keep the figures separately, not together. It's possible also and together. Oops.
Yeah, sure. Like if you can, like, yeah, so what you can do is you can just make the plots and save it in a folder or something, and then upload it on the drive.
Yes, thank you.
The code which we write should be in a separate document, not in the one we copied from the lab 6. Like, should be separately, or can it be the continuation of this document we just explained, like all this classwork?
Okay, so you want to save this file, or I didn't understand your question actually.
Like the homework should be made into the code for the homework should be written in a separate file, or can it be made just in this file we just discussed, lab 6?
So like, yes, so you can save it in a different file. Okay.
Okay.
So yeah, so you can make a copy and then save it as IPYNB only. Okay. Then upload it on the drive. Yeah, but don't edit the original file. The original file
of course we need a copy first.
Always make a copy of this. Otherwise, if one of you makes some changes in this, then everyone will get the same changes. And And if it's incorrect, then everyone will face a problem. Okay. So yeah, so don't make the changes in the original file, just make changes in your copied file. Okay.
Yeah, that was clear. Thanks.
I do it as a continuation. Yes, I save a copy of this notebook, and at the end, where is the instruction, I just insert my code, and
yes.
I don't remove.
Yes.
I don't remove the beginning. Yes, all these explanations. I keep it
Yeah,
like
yeah,
that.
no.
But at the end, there is an assignment, and then we need
And you
to.
can just add the code blocks here.
Yes, upload it in individual folder. Yes, I think everybody received an individual folder where we can keep our assignments.
Yeah, so the images, so you're the, so for the images, so I think you will get a bunch of images, around 5 images, I guess. So you will have to save the images and like save each of the images and yes, save each of the images in a folder and then upload it. I hope this thing is
yes, it's clear. Yes, I hope.